Have you ever looked up at the night sky and wondered how our solar system came to be? This is a question as old as human curiosity itself. Since the dawn of civilization, we've gazed at the stars and planets, pondering our place in this vast cosmic neighborhood. The universe is a colossal expanse brimming with galaxies, each teeming with billions of stars. Among these, our home, the solar system, is but a tiny speck, yet it holds a unique significance for us, for it is the cradle of our existence. Understanding how the solar system formed is not just about satisfying our curiosity. It is about unraveling the cosmic processes that led to our existence. Each planet, each moon, and each asteroid is a piece of the puzzle, a clue to our cosmic lineage. So, are you ready to journey back in time? To explore the origins of our celestial home? We're about to embark on a journey back in time to the very beginning of our solar system. Our story begins nearly 4.6 billion years ago in a dense cloud of interstellar gas and dust. This cosmic cloud, often referred to as the solar nebula, was not just a simple cloud. It was a swirling, chaotic mess of elements, a celestial soup that held within it the ingredients necessary to create a solar system. So, how did this nebulous cloud transform into the well-ordered solar system we see today? The answer lies in the fundamental force of gravity. The nebula was so massive that it couldn't resist its own gravitational pull and began to collapse inward. As it collapsed, it started to spin, much like a figure skater pulling in their arms during a spin, and the spin got faster. This spinning motion caused the nebula to flatten into a disc shape, a cosmic pizza, if you will. This is often referred to as the protoplanetary disk. Now picture the center of this spinning disk. It's getting denser and denser as more and more material collapses into it. And it's getting hotter and hotter too, due to the increased pressure. This is where the magic happens. This is where a star is born. As the temperature and pressure at the center of the disk reached a critical point, nuclear fusion ignited. The hydrogen atoms began to fuse together to form helium, releasing a tremendous amount of energy in the process. This energy prevented further collapse of the disk and stabilized the center. Thus, the sun, our very own star, was born. But of course, the story doesn't stop there. This was only the beginning. The birth of the sun was a pivotal moment, but it was just the first step in the formation of our solar system. And so, our sun was born. But what about the planets? Let's continue our journey through space and time to understand how the planets, including our own Earth, came into existence. The remaining gas and dust in the disk started to stick together, forming planetesimals. Now, you might be wondering, what in the cosmos is a planetesimal? Well, it's a solid object that's thought to exist in protoplanetary disks and in debris disks. These planetesimals are the building blocks of planets, the initial stages of their formation. As these planetesimals continued to collide and merge, they grew larger, eventually forming what we call protoplanets. Imagine a cosmic game of snowball where these planetesimals are the snowflakes. As they come together, they form bigger and bigger snowballs, or in this case, protoplanets. Now, not all planets are created equal. In our solar system, we have two main types of planets: terrestrial and gas giants. The terrestrial planets are the ones closest to the Sun: Mercury, Venus, Earth, and Mars, made primarily of rock and metal. They're like the hard, compact snowballs in our cosmic game. Further out, we have the gas giants: Jupiter, Saturn, Uranus, and Neptune. These planets are composed mainly of hydrogen and helium, with traces of other volatile substances. They're like the fluffy, loosely packed snowballs. The reason for this difference lies in the temperature of the protoplanetary disk. Close to the Sun, it was too hot for volatile substances to condense, resulting in the formation of rocky planets. Further out, where it was colder, these volatile substances could condense, leading to the formation of gas giants. As these protoplanets continued to evolve, they cleared their orbits of planetesimals, becoming the dominant bodies in their orbits around the Sun. Over millions of years, these protoplanets cooled and solidified, forming the planets we know today. Thus, the planets were formed, each unique and different in its own way. From the rocky, crater-filled surface of Mercury to the swirling, stormy atmosphere of Jupiter, each planet tells a story of cosmic collisions, temperature gradients, and the passage of time. This is the beauty of our solar system, a diverse family of planets, each with its own unique journey from planetesimal to planet. About 4 billion years ago, our young solar system experienced a period of intense meteoric activity, a time that astronomers refer to as the Late Heavy Bombardment, or LHB. This was no ordinary meteor shower. It was a cosmic onslaught, a shower of fire and fury that lasted for a staggering 100 million years. Picture this. Our solar system, in its infancy, was a chaotic place. The terrestrial planets, that's Mercury, Venus, Earth, and Mars, were just beginning to find their footing. Then, out of nowhere, they were pummeled with asteroids and comets, a relentless assault that left a lasting impact on their surfaces. The Late Heavy Bombardment was like the universe's way of saying, "Welcome to existence. Here's a trial by fire." And fire it was. The impacts generated so much heat that they melted the crust of these planets, creating vast oceans of molten rock. On Earth, this intense heat may have even created the conditions necessary for life to begin. Now let's talk about the moon. Our moon, that beautiful glowing orb in the night sky, owes its existence to this period of heavy bombardment. The leading theory suggests that a Mars-sized object, affectionately named Theia, collided with Earth. The impact was so colossal that it sent a chunk of Earth's crust hurtling into space. Over time, this debris coalesced and formed the moon. The scars of this tumultuous period are still visible today. The moon's surface is a testament to this, pockmarked with craters from countless impacts. The other terrestrial planets, too, bear the marks of this cosmic bombardment. The Late Heavy Bombardment was a defining period in our solar system's history. It was a time of destruction, yes, but also a time of creation. It shaped the planets, gave us the moon, and perhaps even set the stage for life on Earth. This bombardment period reshaped the faces of the terrestrial planets and gave us our beloved moon. It reminds us that sometimes, in the heart of chaos and destruction, something beautiful can emerge. Fast forward to today, and we see a solar system full of wonder and diversity. Each celestial body, from the sun to the smallest asteroid, is a unique world waiting to be explored. The sun continues to blaze brilliantly at the heart of our solar system, a fiery furnace that has been burning for over 4.5 billion years. Its gravity holds everything together, from the innermost planet Mercury to the furthest reaches of the Oort cloud. The 8 planets that orbit the sun, each with their own distinct characteristics, have captured our imaginations. There's Mercury, the smallest planet, scorched by the sun's heat and scarred by countless craters. Venus, shrouded in a thick toxic atmosphere, is a world of extreme temperatures and crushing pressures. Then there's our home, Earth, the only known planet to harbor life. Mars, our next-door neighbor, is a cold desert world, but its icy poles and ancient riverbeds suggest it was once warmer and wetter. Jupiter, the largest planet, is a gas giant with a strong magnetic field and dozens of moons. Saturn, with its iconic rings, is another gas giant, and it's known for its complex system of moons. The ice giants, Uranus and Neptune, are cold, windy, and distant, with Uranus tipped on its side and Neptune hosting the fastest winds in the solar system. Then there are the dwarf planets, including Pluto, and countless asteroids, comets, and meteoroids that fill our solar system. Each of these celestial bodies has its own story to tell, and their study provides valuable insights into the history and future of our solar system. Today, we are in an era of unprecedented space exploration. Robotic spacecraft are venturing into the farthest reaches of the solar system, sending back stunning images and valuable data. Astronomers are discovering new celestial bodies, and researchers are uncovering new insights about the ones we already know. Our solar system, a cosmic phenomena, continues to inspire curiosity and exploration. So, how did our solar system form? It began with a cosmic question, a mystery that has sparked humanity's curiosity for centuries. We now understand that our solar system was born from a colossal cloud of gas and dust, a nebula, over 4.5 billion years ago. This nebula began to collapse under its own gravity, spinning and flattening into a disk, giving birth to our sun at its center. Around this young sun, dust particles started to stick together, forming larger and larger clumps. Over time, these clumps grew into the planets we know today. The inner planets, including our own Earth, formed from heavier elements, while the outer gas giants formed from lighter, more abundant materials. Then came a period known as the Late Heavy Bombardment, which dramatically reshaped our planets through a series of massive impacts. From a cosmic dust cloud to a bustling neighborhood of planets, the story of our solar system is truly a cosmic tale worth telling.